Okay, today we are going to do a little theory. So near the end of class last time, we did an example of how to do a proof by mathematical induction. And I hope by doing that now you'll have...
Wave the camera. Everyone stopped.
So I hope that by doing that example in class last time, that will give you a context for this theory. And let me also give you a little warning. We're going to prove some theorems here, and the steps in these theorems are a little tricky, and you might see some of this on the final. So I encourage you to take good notes and understand what we're doing today. Okay? Just a little word of warning. Now, what we have here is our one axiom and two theorems. 12.3 is the fundamental mathematical induction axiom. And it's mathematical induction over n. And then 12.4 is mathematical induction over the natural numbers. And 12.5 is a different mathematical induction over the natural numbers. Now, so let's take a look at these. The working equation that we used when we did that proof by mathematical induction, when we proved the sum of the odd numbers was n squared. Is that what we did? And then I think you did, for the homework, you did the sum of the, 1 plus 2 plus 3 plus ... plus n is equal to n times n plus 1 over 2, right? That's what you... Okay, but now in those proofs, we used 12.5. 12.5 was the working one, because look, what does 12.5 say? Because what 12.5 says is we want to prove that p dot n is true for all n. That's on the right-hand side. Are you with me? We want to prove that. And notice over here, this p dot 0 is the base case. Are you with me? And then if you can prove that p dot, well, roughly speaking, that's not quite what we did, but if you can prove that what we did is we proved that
for each individual one, the next one.
If the previous one is true, then the next one is true, right? Now this is a little bit stronger. This is saying that if it's not just the previous one, but the previous one and the previous one before that and the previous one before that can prove the next one, then this is true. So this is a little bit more general. But anyway, this was our working equation. But now what I want to do now is, first of all, I want to give you, try to get us to understand the meaning of 12.3. Okay? Now, 12.3 looks complicated. It is a little complicated. Because what you have on the left-hand side of 12.3 is we have a for all n, right? And then inside the for all n, we have a for all I. You see what I'm saying? Yeah. So you have a for all inside of a for all. So what does that mean? Okay? And on the right-hand side, we have well, p dot true, on all of these, 12.3 and 12.4 and 12.5, the right-hand sides are all what we're trying to prove. We're trying to prove that p dot n is true for all n, right? So do you see that the right-hand sides of these are all the same? Okay. Now, so the first thing I want us to do is take a look at the left-hand side of 12.3 and see what it means. Okay, so here we go. Meaning of the left. Now, LHS is a common abbreviation for left-hand side. And obviously, the right-hand side is abbreviated. Oh, we have. Oh, sorry. Okay. Of 12.3. I didn't realize that. Okay, so there's the meaning. Now, so let's just take a look at the left-hand side of 12.3. Now, 12.3 says for all n, right? So what let's do is let's just take a look at the inside of 12.3 in the case that n is 0. Because when it says for all n being the natural numbers, that means that it's with n equals 0, and with n equals 1, and with n equals 2, and with n equals 3, etc., right? Okay, so let's take a look at the left-hand side when n is 0. So the meaning of the left-hand side of 12.3 when n equals 0. Now, if n equals 0, then what do we have in the body of?
False.
Yes. So we have for all I, range 0 less than or equal to I less than 0, body p dot I. We have this implies what? If n is 0? No.
Or P dot false.
No.
No.
When n equals 0, what's in the body? What's in the body of 12.3? Yes. Does everybody see that?
Uh-oh.
Are you with me on this?
Sure.
Okay. And this equals, and somebody just said it a minute ago, this equals by math. What is 0 less than or equal to I less than 0? False. So that's for all I, false, p dot I, and this implies p dot 0. Are you with me? Is everybody cool so far? Okay. But anytime you have a false here, what does that say? What do you use when you have false here? What? Well, no, you said it first. What? Empty range. This immediate thing we think about is the empty range rule, right? Okay, so empty range. Which number is that?
813. The very first one.
Empty range rule, 8.13.
What's that rule actually saying?
Good question. You want to read it there for us? What is that rule saying? It says that
Star X range false, body P equals U.
U. Now, what does it say about U? What is U up there? Do you see up there the line just above it?
Identity.
That's the identity. Okay, now what's the operation here? This is a for all. So what's the operation?
True.
What's the operation?
All.
It's and.
Identity of and.
So what's the identity of and?
True.
True. Is everybody clear on this one? Okay. So what? So this whole thing is saying what?
True.
True implies what?
P dot
P dot 0, right? Well, does this look? Can we do some more work on this one?
Sure. They're in.
What do you think this? I mean, what do you think? True implies P dot 0. What do you think that is?
The identity of implies.
Yeah,
Left-hand identity. Yeah.
So this equals by the left identity of implies, which is 3 point, what did you say? 73.
So that's true.
So this is, no,
No, it's P.
it's P dot 0. Okay, now, does everybody understand every step that we did here? Are we good? And what we're doing is, now let's go back and look at 12.3. And what we're doing is what's inside the body of 12.3, right? What we're doing is inside the body of 12.3. And we're doing it when n is 0.
Yeah.
Are you with
Does
me?
that mean the other n is 0?
Okay. Hey, wait. You're talking about the right-hand side of 12.3? That's a really good question. And we need to understand that. Okay, so let me ask you a few questions. This I right here in 12.3,
Bound.
it's bound. This
Bound.
n in here, is it bound or free?
Bound.
It's bound to this n. Yeah.
Yeah.
So if we were to expand all this out, would there be an n?
No.
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 So what about this p dot n on the right-hand side? Is it bound or free? That's bound to this n. So are they the same n, yes or no? No. Are you right? Are you with me?
Almost gonna. Almost gonna.
Okay. Okay. Now let's do it when n equals 1. Okay. So this is when n equals 0. Now let's do it when n equals 1. So now when n equals 1, what is the left-hand side of this 12.3? It's for all. What is it? It's for all I, range what? 0 less than or equal to I, less than 1, body what? P dot I, and what does that imply? P dot 1. Now, does everybody see that? Are you with me?
Oh, yeah.
Are we good?
Oh.
Okay, now, but now what does this, let's expand this out.
So for all n range true, so every single n.
Now, wait. What are the values of I here? What are the possible? Just 0. Okay, so if that's just 0, then what do we have? Now, did everybody hear? Did everybody get that? So what this is saying is that P dot 0 implies P dot 1. That's what happens when n is 1. Well, let's do one more. Okay? So let's do it when n equals 2.
Okay.
Okay. Okay, so when n equals 2, what do we have? We have for all I what?
0
I less than 2, body what?
E dot I.
P dot I,
P dot 2.
parentheses, implies P dot 2. So expand this out and what do you have?
P dot 0 and P dot 1 implies P dot 2.
Yeah. So this is expanding. So this is P dot 0 and P dot 1 implies P dot 2. All right? Is everybody clear on this, on what we have? So what do we have so far? What we have is P dot 0. Now, inside that, that's a for all n, right? Okay, so what is it for all? It's P dot 0 and P dot 0 implies P dot 1 and P dot 0 and P dot 1 implies P dot 2 and
Etc.
P dot 0 and P dot 1 and P dot 2 implies P dot 3 and dot all the way up to what?
P dot 0.
P dot n implies P dot. Something like that.
P dot 0 and and P dot n minus 1 implies P dot n.
Infinity.
Well, yeah, to infinity. Okay, so here's the meaning of 12.3. So here's the meaning of 12.3. The meaning of, so let's just write it out. So it's P dot 0 and P dot 0 implies P dot 1 and P dot 1 and P dot 2 implies what? Oh, sorry, I did that wrong. And P dot 0 and P dot 1 and,
Well, doesn't it imply P dot 2?
oh, sorry, wait.
P dot 0 and.
Oh, yeah, P dot 0 and P dot 1 implies P dot 2 and P dot 0 and P dot 1 and P dot 2 implies P dot 3 and ... Now, we actually need some parentheses around here, right? Because this and, we don't want this to be P2 and P0, right? So we actually need, I think we need parens like here. Is this right?
Yeah.
Like that. Okay? And what we are saying, and what 12.3 is saying, but this is for all n. What this is saying is that this ... this whole thing does what? 12, because this is just the left-hand side, right?
Goes to infinity.
It's saying that this whole thing implies what?
For all n
For all n range true, for all n type, this is induction over the natural numbers. So for all n range true, P dot n. In other words, it's true for all n. That's what, this is the meaning of 12.3. Now, does everybody see what that is saying? Now, what we did yesterday, I'll come back to that. All right, now what's the difference between 12.3 and 12.4? Let's take a look at here at 12.3 and 12.4.
12.4 says it also goes backwards.
Yeah, 12.3 says the left-hand side implies the right-hand side. But 12.4 says what?
A mutual implication.
It says it's not just implies, but it equivalves. Are you with me? So how could we prove 12.4? So how could we prove 12.4?
Probably
Using 12.3.
Well, 12.3 says that the left-hand side implies the right-hand side. But 12.4 says the left-hand side equivalves the right-hand side.
So prove it by mutual implication.
So what, we would use, if we would use mutual implication to prove it, what would we have to prove? What would we have to show?
That the right-hand side
That-
implies the right, or follows from.
Yeah.
Oh, yeah, the right-hand side implies the left-hand.
Yeah, we would have to show that and that's what we will do. Are you with me? Now, does everybody remember mutual implication? Here, let's jot this down. Are you with me?
How do you use the axiom?
Well, this is the fundamental mathematical induction axiom over the natural numbers. What we're working up to is 12.5, which is what we actually use, because 12.5 actually has the base case split off here.
Right.
See? So that's what...
So we're actually going to use 12.5.
Yeah, we did use 12.5.
So we're
Right.
going to use 12.3 and 12.4.
No. We will always have the base case, and what will happen, we'll always use 12.5, and this will be the base case, and this will be the induction case. But this is the theory behind it.
Okay.
All right, so we want to know, and besides, there's some neat proof techniques here. And like I said, but for those of you who just came in a little later, some of this stuff might be on the final. I might ask a question about this, so you might want to be diligent in how you take your notes here. Okay, so let's summarize what we just said. 12.3 is an axiom. 12.3 is an axiom. Okay? And we can prove 12.4 can prove 12.4 from 12.3 using 3.86 mutual implication. Did I get that number right?
Maybe.
I actually can't read my notes here. Is it?
No, it's not it.
It's not it? What is it?
That was
380. Yeah. I thought it might not be. Right.
Are we going to do it?
Yeah, we're going to do it. And what is mutual implication? It says P implies Q and Q implies P equivalves what? Yeah, P equivalves Q. All right? And so we already have it. See, we already have the left-hand side implies the right-hand side. So here's how our proof will go. So the proof will go like this. We will prove that the right-hand side of 12.3 implies the left-hand side of 12.3. So we'll prove that RHS of 12.3 implies LHS LHS of 12.3. And now, you guys, what's one of the most common techniques for proving that something implies something? Assuming the conjuncts of the antecedent. So what will we do? We'll start with the left-hand side and we'll get it to true. And in the process of getting it to true, what can we use? The right-hand side as if it were a theorem, right? Okay, so by assuming...
Sure you don't want to use contrapositive.
Yes. Now we say the conjuncts of the antecedent, even though there's only one.
And true. Always assume true.
Thanks for all your help. Okay. All right. Are you ready? Are you up for this? Okay, here we go. Left-hand side of 12.3. LHS. Left-hand side of 12.3. All right.
So let's write down the left-hand side.
Okay, so let's write down the left-hand side. Okay, nice. Okay, so here we go. You want to start, and that's the first step. So left-hand side of 12.3 equals, by definition, you know,
Because it's there.
because it's there. That's why we climb the mountain, because it's there. Okay, the left-hand side of 12 is what? Okay, so what is it?
For all n,
Okay, here we go. For all n
type n.
type natural number,
Range true.
range true,
Body.
body,
For all I.
for all I, range
0 less than or equal to I is less than n. Body p dot I
body, p dot I, does what?
implies p dot n.
Implies
P dot n.
p dot n,
And we're done.
right? Now, if somebody can tell me, oh, you know what? Actually, I said something a little bit, I actually said something a little inaccurate here. I said there was only one conjunct. No, there's not only one conjunct. There's a lot of conjuncts.
There's n conjunct.
There's an infinite amount of conjunct.
Yeah, there's a lot of conjuncts. Are you with me?
Yeah. You can assume any one of them.
And you can assume any one of them.
So
Could you also assume every one of them?
Yeah, but we only need to assume one of them in this next step. Which one?
P dot n.
Yeah. And what do we know about p dot n?
True.
It's true because it's one of the conjuncts. Are you with me? We're assuming here the right-hand side of 12.3. What is the right-hand side of 12.3? It's for all n p dot n. So one of the conjuncts is, okay, so equals p dot n equals true because it is a conjunct. Because it is a conjunct of the right-hand side of 12.3. That was brilliant. Good observation. Okay? So therefore, what do we have? For all n type natural number, range true,
body blah blah blah.
body, blah, 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 for all I, range 0 less than or equal to I less than n, body p dot I, oops, p dot 6,
Implies true.
p dot I implies true.
And then
Zero-
anything that implies
zero
true is
implies.
itself.
Yeah, 0 implies.
Yeah, and that's 3, yeah, that's 3, what is that?
Implies 0.
372. So this, good call, equals by 372.
Right.
3 point. So 3.72 says P implies true, equivalves true, right? So this implies true must be what? True, right? So we have for all n type natural number, range true, body
Range true, body true.
true. Ha ha ha. Body true.
Boom, boom. Done.
No, we got to get it.
Which
Isn't
is
there something that
that's
you
a-
have?
Yeah, well, yeah.
There's a theorem somewhere.
Because we're using assuming the conjunct, so we got to get it to true, right? The whole thing. What?
There's a theorem that says.
9.8. 9.8.
We have it?
Yeah, 9.8.
A 9.8 equals by 9.8
Yep, there it is. True, done.
true done. Boom, boom.
Oh, it doesn't matter what the range is.
It doesn't matter what the range is. Huh?
That's solid.
Is that slick or is that slick?
Is that all we have to write?
Well, that proves 12.4. Now, it's a little bit more complicated to prove 12.5, but we can do it.
We've proved that, I mean, we don't have to say, now because of 12.3 and mutual invocation.
Well, but see, we set that up here.
Oh, okay.
I mean, we already said that over here. So we said, proof, we will prove that the right-hand side implies the left-hand side. And then once we have that, you know, by this one, we have that they're equal. Are you with me? So that's why we set all this up before. So we're done, right? Okay, now comes the one that is a little bit involved, and but I think you'll be able to understand every step of the way. I think. What we're going to do now is we're going to prove 12.5. Now 12.5, and this has an equivalence, right? So we're obviously going to prove it from 12.4. But what we're going to do is we're going to split off this term to get this base case, right? So here's the proof of 12.5. Proof of 12.5. Okay, now what we're going to do is we could either get, start with the left-hand side and get it to equivalent the right-hand side, or we could start with the right-hand side and get it to equivalent the left-hand side. Now, normally what do we do? Normally, what would you say?
Left-hand
Start with the
side.
left-hand side because it's more complicated. But not today.
Not today. Oh, I know what we're going to do. We're going to use 12.4 to turn the right-hand side into the left-hand side of 12.4.
Ah, yes. Yeah. Okay, so we're going to start with, we'll start with the right-hand side. So for all n type natural number, range true, p dot n. This equals by 12.4, which we just proved. Yeah, so you called it right. Yeah? And so now what do we have to do? We have to stick all of this stuff in.
Yep.
Okay, so can somebody,
For all n type natural number, range true.
for all n type natural number, range true, body,
For all I.
for all I
0 less than equal to I less than n.
less than n,
Body p dot I.
body p dot I
Implies p dot n.
implies p dot n.
Done.
Done. Now, who wants to go next? This equals, we're going to rewrite this slightly, by definition of n. Definition of natural number. Definition of the natural number type. Do you remember what's the definition of the natural number type?
On the front.
0, 1, 2, ...
Correct. So instead of writing this as a natural number, let's write it,
Change.
well,
Unit for all n range.
yeah, for all n, we want to put that into the range.
0 is less than or equal to
n.
n is less than.
Right. Okay. So this is going to be for all n, range 0 is less than or equal to n. Body, blah, blah, blah. For all I, 0 less than or equal to I less than n. Body p dot I. Body p dot I implies p dot n. Right? Is everybody good? Now remember, this might.
That's a tricky one.
Okay. Okay. Who wants to split off the first term?
First one.
Yeah, the first one.
Oh, p dot
Because look, well, so let's split off the first term. Now this is tricky. Somebody want to volunteer?
Sure.
Okay, now it's kind of tricky
Page 23.
because
Okay. For all
because the first term.
For all I.
Ah.
What?
For all
Aha. Yeah. What do you mean? What?
What?
For all I.
What?
He is saying for all I, but we have some protesters here.
That's the body. That's it. You write the body with 0 plugged in for n.
Oh, it's the body.
Yeah, that's the trick. Are you with me? See, most people don't. Most people do P dot. Yeah, but it's for all I. What range
0 less than or equal to I.
This is I.
Less than 0.
less than 0?
Body. P dot
Body P dot I
implies
implies
P dot 0.
P dot 0. Okay.
Put
Now what?
parentheses, put all
The whole thing, yeah, the whole thing in parentheses, and then what? And. Now, is everybody with me on this? With the same thing, but now with this being what?
That's
Or just less.
Yeah. Did you hear Mason?
just less.
Just less than, right? Is everybody clear on this?
Yeah.
Okay, so this would be and for all, wait, I'm getting, is it this one?
Yes.
For all n, 0 less than n, body, for all I, range, 0 less than or equal to I less than n, body P dot I, implies P dot n paren. Did we do that right?
Okay.
Okay. Now, I think we can do, you're going to like this next one because we're going to do like 3 steps in one.
Just say by proof of 12.4.
Well, yeah, because what now? What we're going to do now is similar to what we did for 12.5. Because what is 0 less than or equal to I less than 0?
True.
No. It's not true. It's what? It's false. So this is false, right? And so empty range false would be what? Would be what?
Yeah,
True would be what?
True. Yeah,
By the empty range rule, that's the identity of and, which is what?
True.
True. And then it would have true implies
P dot O.
P dot 0. And then that would be what?
P dot 0.
P dot 0. Remember that? Okay, so we'll do all those. So we'll do empty range. So here we'll do empty range rule. Empty range. No, we'll spell it out. Empty range rule. And true is the identity of and. True identity of and, comma. And then 3.73, which is true implies P equivales P. When we do all of that, what do we have?
What's your true identity of man?
You mean implied?
It's just empty.
True is the identity.
True. The empty range rule gives us true here, right? And then true implies P sub 0 gives us the P sub 0. True implied. Are we good?
So P dot 0 and the rest of it.
So we have P dot 0 and the rest of this. Yeah? Is everybody clear on this?
Boom, boom.
You look a little. You look like you're not buying it quite yet.
Yeah, I just don't see why you need to write true identity of
Okay,
man.
for 813 empty range, it has the operator.
Yeah, so P is just P dot I.
But the for all, the for all is and. The operation for all is and so it's the identity of and so true, and so that's where the true comes, and then true. This is similar to what we did,
True
Before.
identity of and by 339.
Yeah. Okay, so what do we have then? We have, so now we got our P sub 0, our P dot 0, right?
Yeah, all.
So now we have P dot, well, not quite. We have P dot 0 and for all n, range 0 less than n, body for all I, range 0 less than or equal to I less than n, body P dot I implies P dot n per n. Now what's the difference between this and what we're looking for?
You know, it implies P n plus 1 and range true at the beginning.
You need the end to be.
We need for all n range true. We need for all I range 0 less than or equal to I less than or equal to n.
Yeah,
And we need n plus P of n.
yeah. See, here we're going from n to n plus 1, and here we're going from n minus 1 to n. Right? Is everybody with me on this? Now we're going to do something that we actually haven't done very much of. We're going to do a change of dummy. Change of dummy.
There's gotta be a better way to do this.
Oh, you can handle it. 8.22 with and what the change that we're going to make is the change we're going to make is n equals m plus 1. I think we need to look at 8.22 for this.
By the way, you've lost
A paren or?
no, you've lost a type declaration.
Yeah, that's all right. We did that. We did that when we did the definition of n. Okay.
We can, I think we can put it back, right?
Well, we can if we want. Yeah.
But
We need to, though.
But we can't.
Well,
Well, we don't have,
It needs to be equal then.
yeah.
I mean, we could have been carrying it through all the way through here, right?
I don't know.
It actually works.
You need to bring it out to split off. Didn't you?
Because now. if-
No. Look. No. I think we could have carried it through.
What
Because-
carry through then?
We changed it and then split off the 0. And
Yeah,
then-
but you didn't need to.
Yeah, but still, if we have this, even if n is natural number, as long as this is in the range, it's still okay. Are you with me? It's legal. Everything that we did is legal.
Alright.
That's not what we're trying to get it to.
Let's just keep going.
Yeah. Okay. Now, you guys, 8.22. I don't think we've ever actually used this before.
Change your dummy?
Yeah.
We know how it works.
We know. I mean, we talked about it, and I think we did. Did we prove it or?
10 billion times.
Oh, this one. I think you did it.
Yeah.
You proved this one, and that you proved this one over the last exam. Yeah.
This is the one that you drill.
Yeah, that we drilled. Okay, but now what does it say? But now we're actually, instead of proving, we're actually going to use it. So now what happens if n equals m plus 1? Because look, what is our f dot y? Are you with me here? What does this say? How do you change? Let's take a look at 8.22. How do you change the dummy of 8.22? What do you do? If we have star x range r body p, and we want to change this from x, what we want to do is we want to change this from an n to m. Are you with me? We want to change it from n to m. All right? So everywhere there is an n, you replace that with what? M plus 1. And everywhere there's an n, you change it to m plus 1 here. And then you just change this to n, to m. Does everybody see that?
Yeah.
I'm not seeing the point of it yet.
Well, you'll see. Okay, so now here what we're going to do is instead of n, we're going to make it m. Instead of this being 0 less than n, it's going to be what? 0 less than what? M plus 1. Are you with me? And then in here, what's free?
The n.
The n is free. So everywhere there's an n, we replace it with what? M plus 1. Okay, so this is going to be
Now we get it.
p dot 0 and for all m range. Now what's the range?
0 is less than m plus 1.
0 less than m plus 1. Body what? For all I, good. Range what? 0 less than or equal to I less than what? M plus 1. Is everybody clear on this? Body what? P dot I. And what does that do? It implies P of M plus 1. We put that in parentheses because it's an expression. Boom. Is everybody clear with this? Okay, so now this equals, by math. Now, what is it? What's another way to write 0 is less than M plus 1?
Changing the body.
0 is less than or equal to n.
Equal to M.
0 is less than or equal to M. So this is P dot 0, and for all M, range 0 is less than or equal to M. Body,
Why didn't you do change of dummy and just do n equals?
just
n?
hold your horses until we get through, and we'll talk about that at the end. Okay, so, okay, and then for all I, but now, how can you rewrite this?
Less than or equal to, or greater than equal to n.
Wait, 0 less than or equal to I. Now what's another way of writing less than M plus 1?
Less than or equal to M.
Less than or equal to M, right? So this is 0 less than or equal to I less than or equal to M, body P dot I, is that right? Equals P dot what? Or P equals P, no, yeah, equals,
That's implied.
oh, is this an implies? You're right, right. Implies here, implies here, P of M plus 1, right?
All you gotta do is switch the other thing back to natural number.
Yeah, and now we can actually, yeah, now we can do, well, okay. And this equals by, but now what? Now what's the only difference between this and this? Oh, wait.
To natural number.
Dummy renaming.
Yeah, dummy renaming.
Well, that too.
So this equals, by dummy renaming,
Eight
821.
Should we do
Correct.
n definition of
Yeah, can we do a definition of natural number?
Okay, okay,
We really want to.
okay. So what do we have? P dot 0 and for all n,
Natural number.
natural number, range, and I think they have it explicitly there, right? What we're trying to prove?
It's true.
Oh yeah, range true.
For all
Okay, range true. For all I, 0 less than or equal to I, less than or equal to n, body P dot I implies P of n plus 1. Boom, boom, and we are done. You guys are good.
Question?
Okay.
Okay, why, when you do change of dummy 822, why can't you do n equals n plus 1 instead of n?
Because this n is not the same as that n, and n equals n plus 1 is false, because n never equals n plus 1.
Well, so we're saying two different ends. We just have to know.
It's the same word.
No, you don't.
That's dumb.
No. Yeah, another.
Watch out, watch out on the argument.
Okay.
In the video, it's like 10 minutes long.
Oh, is it really? Did we spend that? Did we spend that much time on it? That's pretty funny. Well, at least you can fast forward through it. Okay. Well, this is really good. Okay, so next week we're going. Tomorrow, Thursday, we'll start reviewing for the final.
Can we pick a time for the meeting?
And hold on. And so I'll see you then. Okay.